There are different levels of difficulty when you're dividing radicals, and the purpose of this video is to show you the different levels that you have to contend with and some of the things you need to watch out for. Now, anytime you are dividing radicals, this main idea is really important. An expression is not considered simplified if it contains a radical in its denominator. That's what you've got to be careful of. And the process of removing the radical from the denominator is called rationalizing the denominator. This is a phrase that you should be used to, or get used to. Rationalizing the denominator. Now, let's start right in with the problems and we'll talk through what that vocabulary means. Simplify this first problem. We know very easily the square root of 64 is 8, the square root of 81 is 9. Done. There's no trick. Next problem. The square root of 13 cannot be broken down, but the square root of 25 can be into a nice neat 5. Now let's look at that 13. That root 13 is an irrational number. And we're okay having an irrational number in the numerator, but we're not allowed to have an irrational number in the denominator. 25 came and simplified down to a 5, and that gave us a nice clean denominator. It has been rationalized. Now on number 3, this 7 is not easily square rooted, and we need to get rid of that square root of 7 down in the denominator. What we're going to do is reduce the 21 over 7 by dividing by 7 over 7, and that's going to give you root 3 over 1, so just root 3. So in other words, you can cancel an any with an any when you're dividing. 15 divided by 5 is 3, and so this is going to be root 3. So first thing you want to look for is, can I just square root the denominator? And if the answer is yes, do it. If you can't, ask, can I reduce the fraction? Whether it's written as the radical of a big double-decker fraction, or if it's the fraction of two separate radicals, either way, can you reduce the inside numbers with each other? That's the easy level. Now we move on to the medium level. Notice in number 5 that you cannot take the square root of 2, nor can you cancel at all because there's nothing to cancel with. So we have to have a trick. We multiply by root 2 over root 2. What that does is it multiplies by 1. Anything over itself is 1. And anytime you multiply by 1, what you get as the product is equivalent to what you started with. So we're going to have the square root of 4, which is 2 down below, and up above 5 root 2. And that has now got a rational denominator, 2, instead of an irrational denominator, and that's why this process is called rationalizing the denominator. Now the 2's cannot cancel because upstairs that 2 is an any, and downstairs that is an outie outside of a radical, and any's and outies cannot cancel with each other. Number 6. The 6 and the 3 can't cancel. So we're going to multiply by root 3 over root 3. That will give us 6 root 3 up above, and in the denominator, root 3 times root 3 is root 9, which is the whole number 3. Now the 6 and the 3 can cancel with each other, and you can have 2 root 3 as your simplified answer. Number 7, I want to do this in 2 different ways. In fact, I'm going to rewrite the problem all over again before we even start. The first way I'm going to do this, I'm going to do what we did in the last problem. I'm going to multiply by root 32 over root 32. That's going to give us the square root of 32x, and down below, root 32 times root 32 is the square root of 1024, which turns into the whole number 32. But that 32 can break down upstairs. That 32 is a 16 times 2, and the 16 comes out as a 4, and so I'd have a 4 with 2x inside over the 32. Then the 4 and the 4 and the 32 will cancel, giving you an 8, and you can have a final answer here of root 2x over 8. Now, what we did was we we first did the rationalizing, then we did the simplifying. This second approach is to break down the 32 first, 16 times 2, rewrite this as the square root of x over 4 root 2, and then when you rationalize the denominator, you're only going to need to multiply by the root 2 over the root 2, because it's all you need to get rid of is the 2 down below. So now up in the numerator we have root 2x, and down below we've got 4 root 4, which is 4 times 2, making 8. And I think that second way was a little bit easier than the first way. We tend to want to just jump into rationalizing, multiplying by a denominator over itself, but what I'm trying to do here is tell you, caution, slow down. If you can simplify the denominator first before you multiply and rationalize, you can deal with smaller numbers and save yourself perhaps a little bit of time.